have a square root equation and we want to solve. We want to see what can A represent as a real answer. And 4 steps you need to remember for this lesson is basically the following. Step number 1, isolate the radical. You want the square root to be by itself because once it is alone, you're going to square both sides and that radical is going to be gone. And then you're going to solve for the variable that's left. And finally, very important, a big vocabulary word, check for extraneous solutions. I'm going to tell you in a bit what is that in a moment. So let's go ahead and get started with today's problem. Today's problem is this one. The square root of a minus 5 equals negative 2. So step number 1. Step number 1 was isolate the radical. When I say radical, it's basically this little square root. Is the radical by itself? Yeah, it's alone on one side. Perfect. So step number 1 is done. It was already done for us. Step number 2, square both sides. Square both sides. And that's what's going to get rid of the square root. So let's go ahead and get started. We're going to square this side to the power of 2. This side to the power of 2. And what happens here is that the square root and the square are opposites. It's like plus and minus. So they're going to cancel out. And we have ourselves a minus 5 equals. What's negative 2 to the second power? It's going to be positive 4. Okay, guys, we're done with step number 2. Step number 4, I'm sorry, got to learn to count. Step number 3 is solve for a variable. Or in this case, solve for a. So let's leave the a by itself. So in order to do that, we do plus 5, and a is equal to 9. So that's our answer. Supposedly, allegedly, Your Honor. But in fact, we need to do one more step, which is check for extraneous solutions. So, big vocabulary word. What is an extraneous solution? Well, basically, when you're squaring something, you might be creating what is known as a fake answer. And how do you know it's a fake answer? Well, simple. In order to check for extraneous solutions, all you do is, if you know a equals 9, plug it into the original. And if if both sides are equal to each other, it's a solution. If it's not, then it's an extraneous solution. In other words, a fake answer. So let's write the original problem. It was the square root of a minus 5 equals negative 2. Now let's plug in for the a. We're going to plug in a 9. Let's go ahead and solve. 9 minus 5, isn't that the square root of 4 equals negative 2? And the square root of 4 is, actually, it's 2. And other people might argue, well, actually, Mr. Molano, it's plus or minus 2. Yes, plus or minus 2, but since this one is not plus or minus 2 as well, that means that it's only a partial answer. It's only partially correct, so it's not fully correct. Therefore, we have an extraneous solution. And our answer for this problem will actually be no real solution. Okay, so there's actually not an answer for this one. And how do you check? Well, right now we just did this the hard way. Yeah, of course. And now I'm going to teach you a trick with Desmos. If you always want to check whether this thing has a real solution or not, I'm going to show you a little hint with Desmos. Now, Desmos likes to use x's instead of any other letter, a or whatever. So let's use letter x for a. If we find the square root of x minus 5, now we don't want to write it as an equation because Desmos won't recognize it. If we were to move this negative 2 to the other side, wouldn't that be a plus 2? Again, it's the same equation, but we're just moving everything to one side so that Desmos can recognize it. Now, do you understand why then there is no solution? Because a solution is when it crosses the x line. Notice here, the graph starts right there, but it's never going to cross the x because it's moving up. That's how we can tell that this has actually a no real solution.